You're listening to Interchain FM, the Cosmos radio station. If you're seeking alpha in the cosmos, look no further. I'm your host, Chjango Unchained. And today we've got two exciting guests of one of the most highly anticipated projects to have launched in the multi-chain slash modular ecosystem, and that is Celestia. Last time we've had these two on the show, that was more than 2 years ago. So I'm happy to welcome you guys back to the show, Ishmael and Mustafa. Ishmael and I used to work together at Tendermint. If you haven't gotten a primer, I do encourage you to watch the first episode that we've ever done with Celestia, and that's so that we don't overlap with any of the content there. But as far as I understand it, a lot has changed, and Celestia now has data availability sampling and other exciting updates for you. Welcome to the show.
Thank you for having us.
How does it feel now that Mainnet has launched? It's been 2 years, and you guys have overcome significant hurdles like state fraud proofs. How does it feel? Congratulations.
Thank you. I can start. I feel very relieved that we took the first major milestone for this project very successfully, in the sense that everything went very smoothly. To be honest, there was one day I was super nervous, the next day I was very happy, and after that I just felt like every day. After that, now it feels like back to normal business.
Oh, right. Oh yeah, that meme that Mustafa posted.
It's exactly
shipping. Mainnet launch.
I think my flare was a bit up and down a bit, and was a bit longer, but yeah, that meme is very on point.
Yes. And you guys hosted a party last week, right? For Mainnet. How was that? Tell me about it. I wasn't able to make it, but I was definitely feeling the FOMO.
I think it was great. It was a very, very jolly crowd. To be honest, we have we do similar parties on every onsite. It's not it wasn't like a huge rave or something. It was like a small party, and a few people, external folks, were invited. So it was a very nice, celebratory, jolly party, and we danced a lot. And yeah, to me it felt like every other on-site party. But yeah, Mustafa,
No, that's what I was going to say. It's not like some massive, RV rave kind of thing. It's just a little celebration.
That is a testament to your events team led by Nat and Yaz. Celestia has now garnered this reputation of having the most epic game nights. And ever since those pictures of a game night with Super Smash Bros., I have always wanted to attend a Celestia game night, but unfortunately was never able to overlap with that.
I haven't been to one yet, but my first one will be, I think, next week at Dev Connect. But yeah, I think kind of the purpose of game nights is to kind of to bring developers together in a more chill environment. Because usually, you go to Ethereum events or after parties that are kind of more drinking based or more raves, but this is kind of it tends to be more like a chill, more social thing for people in the modular ecosystem to kind of get talking with each other in a more kind of chill environment.
It makes so much sense for the class of people that you're targeting. Celestia needs a strong base of developers to build applications on top of it. You're just infrastructure. And a lot of that demographic tends to socialize and bond over stuff like gaming, probably even better than over alcohol and dancing to live music. I mean, that's sure as hell how I grew up socializing. It was, we bonded over Super Smash Brothers since it was since N64, and now we're here.
Yeah, it's funny that you mentioned Smash Brothers, because on the party there was a corner behind the dance floor where people could also play Nintendo Switch, basically.
Yeah, and I bet you that was the best corner. That was the party corner. There is a significant correlation between someone who games and someone who is more interested in research and technical and probably engineering. What went well and what didn't? Are you able to reflect about the
I think
airdrop? Because there was a lot of community feedback.
the co-founder of Kepler did a really good set about this on Twitter recently, where he went like what went well and what went wrong. Generally, in the Celestia Cosmos system at launch, um, like I think the Celestia launch and the airdrop itself went pretty well. Like the airdrop was really well received because it was a very widely distributed airdrop that kind of like rewarded the right people. We had a significant allocation to developers, for example, who contributed public goods, and around 200,000 people claimed the airdrop. So it was a very kind of inclusive airdrop. There's barely anyone complaining, oh, why I didn't get an airdrop. Why didn't I get an airdrop? This airdrop is unfair. People generally thought it was fair, which was kind of like really pleasantly surprising because I know like with various with various previous airdrops, people have complained about that a lot. But with this one, we put a lot of effort into that to make sure that it's as fair as possible while rewarding and incentivizing the right kind of behavior. The mainnet launch was also very smooth. Like the network was producing blocks weren't being missed, and so on and so forth. The network itself was handling the load. Unfortunately, I think we kind of DDoS Osmosis a little bit and other kind of pieces of infrastructure. But there's a lot of interesting discussions happening from that. Things like how the feed market work in various Cosmos chains and how to improve DOS resistance.
It wasn't directly us who DOSed
No, of
Osmosis. It was
course
our
not.
bots.
Our
Yeah.
bots.
Yeah.
Yeah. So what was going on? People were arbing between centralized exchanges and Osmosis.
And it's probably better to ask like the Osmosis team what exactly went on there. But yeah, I think that's what you described is probably the right explanation.
Right.
Yeah, I mean, I think it was more of it was more of an interesting case study in IBC in general. It's not really Osmosis specific, but it's more of an interesting case study what happens when how IBC relaying works. So like there's several issues with IBC relaying. One of which TV players aren't getting incentivized. So like IBC relayers are complaining that they had to pay very high fees to post IBC acknowledgements on various chains and so on and so forth. And then IBC acknowledgements weren't getting included in the chain because sentiment has not always had, not all Cosmos chains have enabled transaction fee prioritization. So like transactions aren't being prioritized by gas, for example.
There's several elements to this. Some people like Jacob Gadikian claim that it was related to the peer-to-peer storms vulnerability that he was reporting on since 2021. Zaki claims that it's mempool logic that needs to be improved on. And Sunny seems to think that if we just implemented EIP 1559 like mechanisms, that it might stimmy some of the P2P storm overhead. So yeah, all of that. I mean, with P2P storms, the thesis is that if there's basically a surge in bandwidth needs of a network, no matter what, even if it's organic or if it's malicious, that it's going to cause the network to halt or like the blockchain to halt. And his claim is that he could basically halt the Cosmos Hub testnet right now as it stands with actually like relatively minimal, like low cost, with just a handful of atoms, like less than 100 atoms. So that's the claim.
I
But
mean, he tried that for like we worked with Jacob a bit on that, and he tried also to like bring down our testnet. So far it didn't work. I don't know if he like I at some point I think we asked him to stop because nodes were getting out of storage basically like eventually, right? Like it's just a testnet and people have not deployed like terabytes of disks there. But I think but I think what his conclusion was that like Celestia is relatively like immune against that attack that he was describing.
Why is Celestia immune to it? So, I mean,
I think we just set the like parameters like the block
ah,
size, and we
mm,
have additional parameters for the block size, which is not just what is it, the max bytes, but also we have like this notion of the square, and like there's several parameters that dictate how large a block can be, and the minimum of that is such that it won't exceed a certain square size, right? So I think that together with the prioritized mempool that Mustafa mentioned, I think that combination makes it harder. I don't think that like Comet as it
Comet
stands,
BFT.
yeah, Comet BFT is per se vulnerable and you can hold any chain. It has to have the wrong parameterization, right? So that
Yeah, so
I think we
the
got that right.
mm.
Right. Yeah.
Yeah, just so people, if there are engineers who are listening and have the power to upstream parameter changes to whatever chain that they care about, such that they prevent stuff like this from happening in the future. What are those parameters? Like you have a
Uh,
max block size limit,
Yeah, I
clearly.
think it will make sense to like link to our specs for that. And
Okay, all right.
there's
We don't
like
need to talk about that here.
there's the blobs module that has like additional parameters, but then again, it's also all the parameters that are like exist, like the consensus params that exist in Tendermint, Comet BFT also exist in Celestia, obviously, and they were chosen in a very sane way, like very conservatively to yeah to be able to handle load.
The airdrop was a spectacular success. It was widely distributed, and now Celestia is live. What can people look forward to for the coming year?
A very big part of it is that there's been various projects that have been building rollups on Celestia on testnet that I think we can expect to go live over the coming year. So, for example, you have Manta Pacific, which is like an Ethereum L2 that has integrated Celestia on testnet, and they're live on Ethereum, and they're gonna switch to Celestia for cheaper APs. And then you've got Dimension, which is also a really cool Cosmos project, which kind of like lets you deploy Cosmos rollups like Rocket. And they have right now they've got a incentivized testnet running with 700 rollups on Celestia. So they're planning to ship mainnet pretty soon. So I think we can expect the biggest thing we can expect. I think is this idea of like right now on L2 beat basically there's only 30 rollups, but I think it's very possible in the next year you might have a version of L2 beat with like 1,000 rollups, right? Because like the goal there is to make deploying a new rollup as easy as deploying a new smart contract. So yeah, I think we can expect those rollups to all come to mainnet very soon.
Celestia itself has funded the development of RollKit, which is the framework that allows anyone to develop it and deploy a sovereign roll app using Celestia for DA. And then there's Vistara, which is an bonus framework that lets people get all of the requisite building blocks needed to deploy a successful roll app, including giving them access to the hardware that's needed to mount a distributed set of nodes. It lets you build a roll app out of the box and plug and play what DA layer or VM that you want to use.
Yeah. Yeah, I mean, I think you can think of Vistara as more as a infrastructure provider more than a framework. So, for example, you can use Vistara to deploy dimension rollups or rollups with other frameworks like Upstack, for example. They also have tooling to make. They do have developer operation tooling to make that really easy. But I would describe them there's within a category of rollup-as-a-service providers. So there's this idea of rollup-as-a-service where kind of like how in Cosmos, right, you have validators, right? And validators are kind of like, you can kind of think of them as a blockchain as a service. But with rollup as a service, the idea is that you can just upload your blockchain to a service like Vistara, and they will immediately deploy it for you and run a sequence system. And because it's a rollup, you don't need 100 validators to execute that chain. You only need one sequencer that does not need to be trusted if that rollup has fraud proofs or ZK proofs.
If I'm understanding this correctly, someone, if they choose, could deploy an optimistic rollup, kind of similar to the OP stack, and DA into Celestia and have the fraud proofs that Celestia has built work optimistically in case there's any like fraud detected. Or if they want to deploy a ZK rollup, they could do that as well and have
Yeah.
zero knowledge proofs DA'd into Celestia.
That's part of the whole vision of Celestia. Like, it's to evolve the Cosmos vision in a way. Whereas with the idea of Cosmos is that anyone can create their own chain using Dynamite and Cosmos. But that requires you to have a validator. But with rollups, you can create your own chain, but you can get rid of the committees, you can get rid of the validators, and just replace them with a single sequencer that does not need to be trusted because the rollup inherits safety and liveness from the consensus layer.
So this is actually a point of confusion for me as well as several other people who are trying to wrap their heads around Celestia, is that sometimes if you're a roll-up, you could have you're not only the execution environment, but you could also run consensus and only use Celestia for DA, not consensus. So that is a point of confusion because how do you have both? Or
Um,
go ahead.
yeah, so when consensus usually comes up in the context of rollups, it usually comes up in the context of censorship resistance. Because people usually say, okay, well, rollups, how can we make rollups more censorship resistant? And they're like, okay, well, we give the rollup a validator set with consensus. Oh wait, that's just a blockchain again. Why even do a rollup? Let's create a blockchain. But that's a very big misconception, because you don't need consensus for a rollup to have censorship resistance. So for example, you can actually have a censorship resistant rollup with one sequencer by doing what Arbitrum does, for example, which is they have a model where if a sequencer starts censoring you, users can post their transactions directly to the base layer or the data layer to force the sequencer to include the transactions in the chain. So that's like one thing you can do, for example, and that's how Arbitrum does it, for example. Like Arbitrum has censorship resistance, despite the fact they only have one sequence running the model. But also, if that's not good enough, you can still have multiple sequences. But the key thing is that you don't need consensus over the sequences. You just need leader selection, not consensus. People often mistake leader selection. Leader selection.
Oh, leader selection.
Every block you have to choose between a different sequencer, and you can achieve censorship resistance that way. But you don't need a full-blown Byzantine fault-tolerant protocol to support multiple sequences.
Okay. Well, that's interesting. That's you put it in a way that I've never considered before. So, and another thing, you said that the rollup gets to arbitrarily select leaders to do the sequencing?
Yeah, I mean, if you have multiple sequencers, you just need some kind of way for the rollup to select those sequences. And that's usually part of what's called the rollup's fork choice rule. It's just like how in Tenement, every single block, a different validator prefers stop. You just need the same mechanism inside the rollup if you want to have multiple sequences. But you don't need a full-blown Byzantine tolerant consensus protocol.
Sure.
You just need to take the part of Tenement that chooses those validators. But those validators don't need to agree with each other about what the block is and run a whole Byzantine fault-tolerant protocol to agree on the block. Yeah. And the reason for that is because the block is closer to Celestia.
So basically, it's not a fork choice rule; it's more a leader selection algorithm, right? Like in Tenement, you choose like who will be the next proposer. So that's determined from like how much is staked, and there's this proposer priority internally, and something like that could exist where you bond a token but and have like some prioritization, like some deterministic selection, or even non-deterministic. That doesn't really matter. Like some leader selection mechanism, and then that's the one who gets like to be the next sequencer for that block, right? Like that's all you need. You don't need, as Mustafa said, you don't need to like do multiple rounds of voting to agree on a block. So that's a BFT part that is not necessary.
And that is the part that the Celestia DA layer is responsible for.
Yeah, I mean, you
So
just post the block basically, and then the blocks get ordered.
I wonder why this is not the status quo in the EVM Ethereum community. Like they have, as far as I know, they have trouble allowing their rollups select the leaders. And in fact, they need additional layers of abstraction like espresso or eigenlayer in order to do that. Why is it different?
Well, as far as I know, yeah, I mean, current Ethereum rollups, they don't have multiple sequences, but but like they can still be censorship resistant. So, for example, as I mentioned with Arbitrum One, like Arbitrum One has a level of censorship resistance, even though there's one sequencer. By having this model where users can force transactions to be included by posting them on chain, directly to the L1. But yes, certain other layer twos and rollups are currently exploring having multiple sequences. And I think there's a few people working on this. So, for example, like Starkware is actually looking into using Tendermint as a rollup sequencer. And then there's also another company called Espresso Systems, which is also developing decentralized sequences for rollups.
Yeah, so that's what I'm saying, that in the Ethereum community, their design space is converging around adding extra layers of abstraction in order to allow for arbitrary round robin uh, design to figure out new leaders. But here in Celestia it sounds like that property is built in, or am I
Oh, I mean,
misunderstanding?
it's built into Ethereum as well. It's just like Arbitrum uses that ability. It's just how you want to achieve it. But as I said, I personally think using Tendermint for a rollup is very overkill. Or having a full blown Byzantine fault tolerant protocol for your rollup is not necessary. It's just fundamentally not necessary when your rollup is already inheriting ordering from the base layer, and that includes Ethereum rollups.
Doesn't okay. All right. So if I mean we're getting philosophical here, but I'm wondering if a rollup is completely BFT, then doesn't that make it an L1? And it just has like a tether to the main chain?
I mean, yeah, kind of. But like, what is a layer one? Like, yeah, it's its own chain, but the rollup is also its own chain. It's just like it has its own consensus, yes, but like depending on how large that set is of sequences, like if it's three sequences doing Tendermint, for instance, like if there, yeah, you don't want to rely on that anyways. So like you will have to rely on a different layer for the security anyways. So I guess like yes, philosophically it's argued that yes, that's a layer one. Practically from like the social understanding of like the security of the chain, I think you would look back to where is actually like where's the where does the block data actually materialize, and that happens like if it's a Celestia rollup, it will happen on Celestia still, right? Like, and if it's an Ethereum rollup, the like it's even the state that like kind of materializes on via fraud proofs or something, or like commitments to the state on Ethereum as well.
In a sense, if Starkware ends up using Tendermint and as BFT, that ultimately looks like what Babylon is trying to do, where Cosmos app chains are BFT and then they are checkpointing into another main chain, Bitcoin, to inherit its security and censorship resistant properties. Those models start converging, and then the lines between what a layer 1 and layer 2 start to blur.
The whole layer 1, layer 2 spiel, like, or the wording is centered around there's one main chain, and that's the chain, that's the only layer 1. Everything around it is layer 2. And I think, like, in a multi-chain world, these words, like, the definitions do not make that much sense, to be honest, because, like, everything that is producing blocks you could argue is the layer 1, right? But does it anchor its security into something else? Then not really, right? Like, then you'd argue is like it's a layer on top of another layer that, like, actually secures the thing.
Given that we're here now and we've established this baseline, does what Vitalik claimed about having layer 3s and layer 4s and basically n number of layers on top of a settlement make sense? Or should it stop at layer 2?
Well, what did he claim?
I mean, his thesis is that blockchain should infinitely vertical scale on top of one monolithic main chain, right? Because theoretically, if you keep stacking rollups on top of rollups on top of rollups, but ultimately checkpoint into a main chain that is Ethereum, then ostensibly that could scale to you know, infinite numbers of rollups and hundreds of millions of users.
I don't think it's bad to have alpha-keys necessarily. I can see like some reasons for having alpha-keys. Like it's probably the case that an L1 probably can't handle. It probably can't handle all the L2s it can. So it needs to, assuming that it's scalable enough. There could be some advantages to L3s. Like you might want to settle to a settlement layer with different kinds of properties. Like maybe you want to settle to a ZK settlement layer that actually supports ZK opcodes. But obviously, the disadvantage of that is that you get more fragmented liquidity.
Imagine if the industry does converge on vertical scaling on top of one main chain, and let's say that's either Celestia or Ethereum, and now you've got a layer 2 full of L2 rollups, but then you've got like this entire new set of rollups as layer 3s that are DAing into the layer 2s that are DAing into the Celestia DA layer, the layer 1. And then now like now extrapolate that infinitely to layer n, and now you've got basically like nested data blobs. It's like, do you think that model makes sense? Or,
Well, I mean,
can it just stop at having infinite amounts of layer 2s, just DA? Because why do you need to stack them on top of one another?
yeah, I mean, ideally, you don't want to stack them too high because like interoperability and composability becomes a lot of pain. But this was actually very shocking proposals by Vlad Zampier in the kind of early stages of Ethereum 2.0. Like it was originally like he was originally proposing to have a tree-based sharding scheme for Ethereum to scale Ethereum, where it's like instead of having vertical sharding, you basically have shards structured in a tree, and then it's like if you want to move funds between shard A to shard B, you have to like go to the root of the tree and then back down, and that's obviously like quite a lot of hops. But there's also I think there's a project called Fractal, which is like a ZK rollup based ZK rollup based project that is proposing kind of like a tree based rollup ecosystem, and they propose like a bridging mechanism between like let's say L7s and L7s in different parts of the tree that is more efficient than having to go through up the whole tree and down again. It's called Slush. I don't know if you
Slush.
heard them.
Let's move on from the world of purely theoretical. Celestia is not really useful unless it is hosting hundreds of end user applications. What are the applications that you guys are foreseeing, looking forward to? Are you confident that once you find the killer application DAing into Celestia, that it can and will scale to, let's imagine hundreds of millions in daily active volume.
For sure, and I would also say like this is kind of like a general, question for crypto and Cosmos as a whole. Like I would argue that it's not for certain that crypto has actually found any product market fit whatsoever, except for stores of value like Bitcoin or ETH. There's been some successes with things like NFTs and gaming, stable coins definitely. But we're seeing some of those experiments in Celestia as well. Like we're seeing like gaming and NFT projects are very interested in Celestia and they're building stuff on Celestia because a lot of gaming projects require a high level of data bandwidth. So, for example, there's an interesting project. There's this project called Curio in August, and they're building kind of gaming engines on top of Celestia that would handle kind of like way more complicated games than you might do on Ethereum, for example. Like for example, Curio actually has like a real-time strategy game running on as an EVM rollup on Celestia, for example, and that fundamentally requires rollup technology because you have to modify the EVM. You can't just use the EVM as is. But we're also seeing other experiments in areas like DeFi. I think hasn't deployed the DEX as a rollup on Celestia. And on Dimension, there's also a lot of cool projects. So if you go on the Dimension portal, there's about 700 rollups, and you can kind of click on them and go on their websites and see what they do. I think there's one of them is like a crowdfunding rollup, and there's a few other games as well on there.
From where we are now, which is close to the end of the year in 2023, it seems like the narrative arcs that are going to be taking hold come the next bull market are going to be RWAs, social tokens, or DeFi, more NFTs, but now applied to the real world, and a lot of GameFi. We'll see how the world turns out come the next bull market. I'd like to move on to data availability sampling, since that was a major feature alongside your mainnet release. Why is that important?
It's important such that you have the guarantee that the data was actually published, right? Like Celestia is all about data availability, and like how do you as a client of the chain verify that the data has been published without like being forced to actually download all the data? So data availability sampling is a technique that allows that. Like it allows you to download a small portion of the block, like 1% or like even less, and have like almost 100% certainty that like all the data is available. Imagine all Cosmos zones would submit their block data to the Cosmos Hub, and then can verify that the Cosmos Hub actually like ordered these, but without having to download all the massive blocks of the hub. So this is basically Celestia, and sampling, yeah, as I said, is like a probabilistic technique that enables you to verify that.
It's kind of like an SPV for your rollups. Like if your rollups did light verification of headers, with that light verification, they're able to see that provably Celestia did do the work that it said it did.
Yeah, exactly. And it's very inexpensive to run such a light node that does data availability sampling compared to like a full node that would download and verify all data.
That's what Vistara has started with too, because like with the Celestia mainnet launch, Vistara actually opened up the ability for people to self-serve their own suite of light nodes for Celestia. Nick White launched his light node using Vistara, using Vimana. I could see a world where in a year from now, people running Vimana nodes are like, that'll take the most market share of people running light nodes for Celestia.
Ideally, to really get light node adoption, we need those light nodes to actually be adopted by wallets, or like to be integrated into wallets. I don't think like running light node is cool on the command line, but I don't think we can expect the average user will care about that much. Like in the future, users should be running light nodes without even knowing. Like light nodes should be integrated to MetaMask or Kepler instead of connecting to Infura or Alchemy or some centralized RPC endpoints. They should be running a light node and downloading these block headers from the network directly. So that's not like what we're trying to achieve there. And there's been some work on creating a Rust version of Celestia node so that you can run it in a web browser by compiling it to WebAssembly. And that will be like one step to be integrated to the browser wallets as well. Like if you look at Bitcoin, for example, Bitcoin has very good light node support. If you install the Bitcoin wallet on Android, which has like 10 million installations, that wallet does not connect to any specialized RPC. It runs a Bitcoin light client and it connects directly to the network and it syncs block headers and downloads data from other nodes. So it's definitely feasible. Like we know it's possible because there's literally 10 million installations of the Android Bitcoin wallet. But it's a shame that we haven't had that kind of like after Ethereum was created. Nothing has had as good as light client support as Bitcoin has, and that's kind of like a very important thing that differentiates Web3 from Web2. Like you're not supposed to be just talking to some centralized database that tells you what the state of the chain is. You should be able to verify it yourself.
I cannot agree more. So I'm going to reframe what you just said in less big brain terms and more layman's terms. What Mustafa just said is okay, look at the problem. The problem in Ethereum is that there is a huge centralization choke point that overnight dApps on Ethereum rely on. And if that choke point goes down, then that means that 90% of the apps basically stop functioning at 100%. And so that's a big vulnerability. And that choke point is, when you open MetaMask or if you try to use Uniswap or SushiSwap or whatever your favorite app is, OpenSea, all of the functionality required for those apps to work requires that they ping a centralized RPC that is run by Alchemy or Infura. This is due to the fact that Ethereum is too heavyweight for any average user to run a fully verifying node on their own. So you can't really catch up to the chain tip, fully verify every single transaction that has occurred on Ethereum from day zero, every single transaction that has been executed on every single smart contract that has ever been made on Ethereum, and be able to do that independently. So what you have to do is you have to rely on a service provider, a centralized one, a company that was bootstrapped by Joe Lubin's company, Consensus, and Infura does the verifying for you. So you're effectively handing off the sovereignty and trusting a centralized company to give you data that it says is true and that they've verified. So this opens up a critical attack vector for state level actors to just say, okay, well, if we want to shut down Ethereum, we just go to Infura, really. And 90% of the functionality of the network just like overnight. So that's a huge vulnerability. And I'm ecstatic that Celestia has, put that back on the list of priorities so that this industry doesn't regress back into that kind of centralized state. Because with Bitcoin, at least, this is they offered the model, right? And this was actually the thesis that Jay Kwan originally had with building Tendermint, which is that you, with your phone, should be able to run a light node that can lightweight verify what's going on the chain yourself so that it doesn't need to ping some centralized RPC.
Yeah, actually, it's not just Infura doesn't just only have the ability to like shut Ethereum down. It also has the ability to give false information about the state of the chain. Like it can give incorrect balances, for example, or it can say a certain balance doesn't exist, for example. So you can imagine that they might get like a government order to say, hey, you should ban this address, to say that this address has a zero balance, for example.
Yeah. So with OFAC sanctions, that's obviously going to enable the government to do a lot more of that under the pretenses of fighting terrorism and AML and all that. And Infura, uh, as far as I know, being a US soil domiciled entity, is going to have no choice but to comply. Okay.
It's not just about the US either. It could be like China could get them to do that, or like any government could have a government order on it. They would have to comply with.
That is not to say, complying with government is bad, but to say that given that at this point we know there's enough corruption for any individual to be skeptical of their intentions, that maybe non-compliance isn't necessarily immoral. Let's just say. I want to talk about Celestia's applicability. I want to harken back to what Sunny used to say about Celestia. Like this was what he thought of Celestia since Cosmoverse 2, so last year, 1 year ago. So I don't know if his stance has changed, but I'm going to frame the use case that Sunny came up with for Celestia, and I'm interested in hearing your guys' take, like the word from the horse's mouth, to see what your take of Celestia's use case actually is, because the chasm is going to be interesting. Because when Sunny was learning about Celestia, his question was like, okay, why do we even need this? His conclusion was that given the existing chains, if they need to use Celestia for DA, in what scenario is Celestia going to actually be useful? And his conclusion was that it's only going to be useful in the very edge case of edge cases. So in like the 1% edge cases. And that's if, let's say, a chain halts. Let's say Osmosis halts. It goes down, service gets interrupted for 7 days, and then it comes back. So his take is that Celestia would be able to restart or basically continue on where the Osmosis canonical chain stopped, and then continue providing service.
You could also argue that Celestia would be useful for a chain where like the core business model is essentially not to secure the chain, but like some other application. I mean, Osmosis can't just like become a roll up on top of Celestia easily, because like if you guys want to deploy threshold encryption, and you need like tight integration into like actually the consensus and the mempool. That's my understanding, at least. So there might be other reasons not to do it, but like imagine you just as a project want to focus on your core business and not spend inflation and like a lot of your tokens on securing the chain and paying validators. I think that's also one good reason to choose Celestia as your consensus service instead of relying on the existing validator set, right? Like that, there might be chains where it might just become infeasible to print as many tokens such that like validators can even cover their costs. That could also be a good reason.
I think that's a bigger reason. Like many Cosmos chains aren't profitable in the sense that it's not profitable to run a validator on these chains. Like it's just not feasible. It's just not realistic to expect that. Okay, if you want to try to create an interchain with billions of chains, they're not all going to afford having 100 validators on there re-executing the same transaction as 100 times. You need a more sustainable way to run the chain. And with Celestia is more sustainable because you don't need 100 validators on the chain. You can just inherit that consensus from Celestia, and you only need one rollup sequence rule to execute the transactions, but have data posted to Celestia to order those transactions.
Is there a scenario where an existing already BFT layer 1 like Osmosis or Akash or Stargaze could transition and migrate their stack as a rollup on Celestia and then slowly wean away the BFT properties of their chain to completely like offload that responsibility to the Celestia DA layer?
I find it very plausible, and I don't think it's like something we won't see. It would be very plausible for some projects to do this.
It sounds to me that for applications using Celestia for its intended purpose to make sense is if they're a new rollup. Probably doesn't apply so much for chains that already exist and have BFT already.
If the project like it's a big project, then yeah, it probably does not make so much sense. Like for instance, like if you pick Osmosis again or the Cosmos Hub, I think like it doesn't really make so much sense. But like for other projects, it could make a lot of sense still, like even if they exist already or not. And I mean, there could be also other reasons for migrating like into or like turning into a Celestia rollup instead of being your own zone. Could also be like, okay, let's save that cost and like reinvest like into a large ecosystem that's already existing, or something like that, right? Like could also be non-cost reasons to switch over. So basically, oh yeah, I like that vision, and our community is very aligned with that, or some. So could have there could be many reasons to do that.
Mhm,
And I'm pretty sure we will. It's not something that will happen very very often, I think, but like I'm sure it will happen, and it's at least I found it plausible. It's very hard to predict like how these things will turn out, right?
mhm. I would like to hear your thoughts about where we are in the development of the Web3 space at a tech stack level compared to Web2's evolution. To me, Celestia is Gen 4 infrastructure, right? Gen 0 is Bitcoin. Okay, you've got an app chain, layer 1, it does one thing. Gen 2 is Ethereum and EVM like systems, monolithic stack, and generalized execution environments. And Gen 3 is Cosmos, where you have app chains that now can basically be their own Bitcoin with their own applications, but then talk to each other still without giving up any of the interoperability. And then Gen 4 is Celestia, which I don't need to go into because you guys know. So to me, it seems like we are moving more and more towards modularity. And that's similar to how Web 1 evolved into Web 2, where there's just these protocols. And then suddenly you have frameworks that let you compose all of those protocols together to ultimately create a website. Then you have basically like giant consumer facing applications, killer apps like social networks on top of all of that. It seems like we're moving in that same direction, aren't we?
Yeah, Web3 infrastructure and tooling has a long way to go. To me, it's like the benchmark is like think about all of those applications that people have been dreaming about Web3. Like think about like okay, let's build decentralized Dropbox, let's build decentralized Uber, let's build decentralized Airbnb. But where are those applications? Like they don't really exist yet. I think like we need to keep iterating on the infrastructure and tooling until we can actually get there. Until there's like decentralized applications become very easy to build, or as easy to build as Web2. And I think rollups can help us to get there because with application specific rollups, because you only need one sequencer, it kind of like gives you very similar infrastructure to Web2, but with the trust assumptions of Web3. A sequencer inherits security from the base layer, and that's a very important step in helping us to get there.
Celestia has demonstrated great foresight on what the industry is going to look like because this is a project that started in 2018. Do you imagine that where we are now could be the end state of crypto, or how do you imagine the space evolving in 5 years from now? Is it still going to be rollups, or like just further even modularizing the stack?
To me, rollups are like the same state as the evolution of the kind of web as when the cloud came around, or like this idea of virtual machines. Because to me, like rollups are basically virtual blockchains, right? So you can create your own blockchain without needing to create your own consensus layer. So like the cloud was very similar because you had virtual machine. You could deploy your own machine without needing a physical hardware, and that opened up a lot of things. That opened up the ability for people to experiment with their own technology, whereas previously before, to create a website, you had to use, let's say, PHP or MySQL. But then you had people could experiment a lot more and kind of web technologies, like you have Docker containers, you have Rust, you had Ruby, for example, and all these different frameworks. So I think we're still going to have rollups for the foreseeable future, but we're going to see a lot more different execution environments. And instead of just having everyone using the Ethereum virtual machine or EVM or even the SVM or WASM, we're going to have a lot more experiments in different kinds of execution environments. And that allow all kinds of things, just like how Q has modified the EVM to literally add a real-time strategy game as an opcode to the EVM.
Do you think that the space for innovation on the consensus layer has relatively plateaued compared to innovation on the VM layer?
I mean, I think like consensus is not the bottleneck. I wouldn't say it's plateaued, but like if you look at Ethereum or Bitcoin, for example, the reason why, or Ethereum specifically, the reason why transaction throughput is not high is not because proof of work or proof of stake with the consensus mechanism they use, or Nakamoto consensus or Gasper. It's not because that doesn't scale. It's actually a pretty efficient. It's a pretty efficient consensus mechanism. It might have higher latency than Solana, for example, but the fundamental reason it doesn't scale is because of the execution environment. The fact that Ethereum is not parallelized. That's why the Solana virtual machine has improved that by being parallelizable. And you've also got other projects like Fuel that do that. Yeah, so I do think like there's a lot more potential for innovation on the execution environment, which is really where I think the rubber meets the road when it comes to building applications. Then from the consensus layer, which is kind of like has a much more basic role, which is just to order transactions. Like I see consensus as more similar to TCP/IP. Like it doesn't really need that much. It doesn't need too much innovation. And then the execution layer is more closer to the actual application layer. Like it's more closer to HTTP, for example.
Maybe my understanding was wrong, but I thought parallel execution, I guess that's in the word. I thought that was happening on the consensus layer. So that's on the execution layer?
Yeah, it's solely on the execution layer. Like if you modify Ethereum, you can Solana could. Actually, like, Eclipse is a good example of this. Like Eclipse is actually bringing this Solana virtual machine to Ethereum as an Ethereum rollup. They're literally building an Ethereum rollup that uses the Solana virtual machine as an execution environment.
Yeah, and then what are they using? EigenDA?
No, they're using Celestia.
Using Celestia. Now I'm trying to piece the whole picture together. In Ethereum, they don't really have this decentralized sequencer abstraction layer, or they're trying to solve that. Would that be solved if a rollup, any Ethereum rollup, uses Celestia to DA, and then the Celestia acts as the middle layer to then checkpoint into Ethereum main chain?
I wouldn't say that problem. I wouldn't say the sequence problem is related to what DA layer you use. Like whether you use Celestia or Ethereum does not really change that. Like you can use either.
So then I'm not understanding how Eclipse is bringing SVM to Ethereum by DAing into Celestia.
Eclipse is a rollup. It posts its block headers to Ethereum, so it sells to Ethereum, but it posts the actual transaction data to Celestia. And then
okay.
You have
Okay, so it's more like this is the rollup, and then it's doing this to Ethereum and Celestia, and it's using those two layers for two different functions.
Yeah, exactly. And then we have a bridge to Ethereum called Blobstream. Where we relay Blobstream.
Oh, Blobstream.
We're relaying the Celestia block headers to Ethereum, so Ethereum smart contracts. can verify that certain data was included in Celestia. So that means that you can create an Ethereum rollup or an Ethereum L2 that posts its headers to Ethereum, but posts its transaction data to Celestia, and then the smart contract on Ethereum, that the bridge contract for the rollup can verify that when the headers are posted, the actual data was also included in Celestia.
That covers everything that I wanted to cover. Are there any last comments that you guys want to make? Housekeeping notes, how people can follow you?
Yeah, the best way to follow and learn more is to go on the ORG website. They have links to everything from there, from submitting data and receiving it from Celestia, from the developer documentation.
Any last comments, Ishmael?
I mean, for developers, I would recommend to follow our GitHub repositories as well, and yeah, we will also eventually do like dev calls or core dev calls, similar to like what Ethereum does, because we want to move away a little bit from the purely on-chain governance model that a lot of Cosmos chains use, and so I'd recommend following the Celestia improvement proposals and the dev calls if you're a developer, and especially if you're a protocol engineer and want to weigh in for improvements on the Celestia base layer.
All right. Thanks for coming on Interchain FM. I am so glad I was able to talk to you guys and dive deep again on the technology. Hopefully, for those of you who are listening who are confused about Celestia, now have a better understanding of Celestia. And if you're a developer, I would encourage you to start deving.